Hello, we're just going to, in this video, look at some practice questions about force for GCSE. So figure 1.1 shows a 0.5 kilogram mass hanging freely on a length of steel wire. Here's the mass and here's the wire. Use labelled arrows to indicate the direction and line of action of each of the two forces acting on the 0.5 kilogram mass. So here's the mass. It's got a weight, so we draw the arrow pointing down towards the centre of the earth. Nice straight arrow, and the tension needs to be the same magnitude. Newton's third law needs to be equal and opposite. The force needs to be of the same type. So that's drawn up. If we have a look, it says here now the acceleration of free fall is 9.81 meters per second squared. Name and calculate the value of the two forces which you've indicated. So the first force is the weight, and the second force is the tension. The weight is the mass times g, which is 0.5 times 9.81, because you've got half a kilogram mass, 4.9 newtons. The tension should be equal and opposite. So this here is not correct. What we need to should have written there is 4.9 newtons, the same as the weight. So the tension needs to be equal and opposite of the same magnitude. That means the same size. Suggest what causes the two forces to act on the mass. So the weight is caused by the gravitational pull of the earth, and the tension is caused by the pulling of the string, pulling force of the string. Question 2. A child of mass 40.0 kg sits down on one end of a seesaw. The pivot is at the centre of the seesaw. There are 4 sacks of sand, each with a different mass, as shown. Explain what you need to do using the sacks of sand to keep the seesaw in balance. So, because it's the same distance, x will be the same distance away from the pivot as the boy or the child. Therefore, we need to have the same mass. We're in the same gravitational field, so we need the same mass. So we just need to add 40 kilograms to point x. It's very straightforward. So how do we do that? Well, we can add the 30 kg and the 10 kg sacks. That's what needs to be written here in your answer as well. You need to be more explicit than just saying add 40 kg to the seesaw at point x. You need to also explicitly say add the 30 kg sack and the 10 kg sack both to point x. B. The next child in turn weighs 50% more. How would you balance the seesaw with the sandbags? So the total mass of the children, so you've got your original child at 40 kg and the next one's 50% more than that, is going to be 40 plus 20. So the mass of the second child is 60 kg. So therefore, if the second kid, this kid gets off and the second child jumps on, is now going to be 60 kg here. So you've got to add 60 kg to here to keep it in balance. So how could you do that? Well, you could add the 30 kg and the 20 kg and the 10 kg bags to point x. If the 30 kg and the 20 kg were already there, you just add this third one to point x. Part C, with the seesaw now in balance, how would the seesaw be affected by another child of 50% more mass standing exactly at the pivot on the seesaw? Well, if he stood on the pivot, then it doesn't affect what's going on at either end if he stood right there at the pivot. So the seesaw would remain balanced, the reaction force to the ground on the seesaw would increase. So what that means is if there was a child standing at this pivot, then all that would happen was it would be pushing down on this part of the seesaw more, so the reaction of the ground up would be increased, but it would not affect what's going on at the ends of the seesaw.